Okay, so review chapter 3. So all of this stuff, graphing is going to be on the final. We can do it. 1:19:22. Our objective is basically we want to review linear equations and their graphs. Right? So hopefully this is a review. Hopefully as I go through that you'll go, oh yeah, Mr. Davies, I totally get it, right? Okay, y equals 5. Y equals 5. Anybody remember what that looks like? Y equals 5? Plain old y equals 5. Anybody remember? Okay, it's going to be a straight across horizontal line at 5. So I'm going to go up to 1, 2, 3, 4, 5. And it looks like that. Y equals 5. We could have written it as y equals a 0, x plus 5, but that would be silly. Is it a function? Do you remember what defines it as a function? One way is, does every y value or every x value have exactly one y? Yeah. Or remember that vertical line test? Remember the vertical line test? So this point here has one y value. One y value. So yeah, yes, it is a function. Is it linear? Is it straight?
Yeah.
Okay, so yes. It is straight, right? Okay, number 2. How am I doing? Am I going too fast? So if I want to graph number 2, what will you think is the fastest way to do it? What would you do to graph number 2? Yeah, let's do the cover-up method. So if I cover up the x's, I'm letting x's equal 0. So let x equals 0. So if I cover up the x's, I get y equals -4. 1, 2, 3, 4, right? And if I let y equal 0, so I cover up the y, I get a 4x equals 20 or x equals 5, right? So I'm going to go 1, 2, 3, 4, 5, and I'm going to graph it. Okay. Now, is this a function? Yes or no? Every x has exactly one y plus. Let me see if I can remind you of this thing called a vertical line. Remember the vertical line test? I'm going to show you. Vertical line test. Will it ever touch the graph twice? No. So it passes the vertical line test, which shows that every x has exactly one y. Something like that would be curvy like this would show an x having 2 y's, and that would not be a function. Why do we do functions? Because I would hate to go to the grocery store, have them charge me 2 different prices for one item, right? One thing and one price, right? It just doesn't make any sense. Okay. So yes, it is a function. Is it linear? Is it linear?
Yeah.
It is linear because it's straight, right? So I'm going to say as far as function, yes, definitely. Is it linear? Yes, because it's straight, okay? Okay, now, let's go ahead and graph. -2, -5, -2, 5, 1, 2, 1, 2, 3, 4, 5. -1, +6. 0, 7, -1, 8, and 2, 2, okay? Okay, state, domain, and range. Well, domain is just my x values. Okay, so there they are. There's my x values right there, right? So I'm just going to say, okay, my x values are -2, -1, 0, 1, 2, right? And my range are my y values. my y values, let's see, there they are for me. I've got a, oh, that's a negative 1. My bad. 5, 6, 7, 8, and 2. Am I going too fast or am I doing okay? Let me slow down for a second. Slow down for just a second. Okay, so I've got my x values and my y values, but something's wrong with my x values. I don't know if you guys see it or not, but something's wrong with my x values. Because is this a function? I don't think so. This is not a function. This is a problem right there. In fact, you can see it on our graph. So no. Negative 1 has two values. Negative 1 pairs to 6 and negative 1 pairs to 8. You can't have that. Negative 1's got to have one answer, not negative 1 has two answers. So no. Now, discrete or continuous? Discrete means this. It stops and starts, stops and starts. Continuous, this is continuous. It just goes on. Nice verb. This is not continuous. This is actually discrete because it jumps, 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 jumps. Continuous means it's a nice continuous flow. This one's discrete, okay? Discrete means it jumps all over the place. It stops, it goes, stops, it goes, okay? 4, pretty much what we did in our warm-up, right? I'm just going to plug in negative 2. So it's really 3 different questions. 3 different questions. F of negative 2. We're going to plug in negative 2 for x. So I plug negative 2 in for x. So f of negative 2 is negative 4, negative 7. F of 0, we just plug 0 in for x. So if I simplify that, I get negative 3. And f of 3, just plug 3 in for x. 6 minus 3, and I get 3. These are really points on a graph. These are really points on a graph. Girls, you're back.
We're back.
Everything positive, I hope, huh?
Please excuse this interruption. Will the following students please report to the testing area? Ivan Alejandro,
So Ivan.
Christopherson, Sidlali Espinosa, Nayeli Fernandez, Rome Goodfellow, Carly Ostrin, Jimena Ramirez, Connor Reyes, Alejandro Romero, Angel Sandoval, Hunter Stutzman, Cole Warman, and Tom West. Thank you.
Okay, let me keep going. Girls, you got your review in front of you? Yeah. So, number 5. This one's different, and you got to be careful. It does not say, it says fx is equal to 2. Fx, so instead of writing f of x, I'm going to write 2. Make yourself draw that little arrow there, okay? I'm not going to write f of x. I'm going to write, instead of writing f of x, I write 2. So 2 is equal to 4x minus 10. And I want to find x. And I want to find x. So I'm just going to solve, right? I'm just going to solve. Plus 10, plus 10, 12 is equal to 4x. Divide by 4, x is 3, okay? You gotta be careful. You're not going to plug in 2, you're going to set it equal to 2. Okay, am I going slowly enough? I'll wait for you. 6, how are you going to graph it? How are you going to graph it? Yes, just do the cover-up method. Totally agree. So if let x equals 0, and I'll have a y equals 3, right? If I let y equals 0, then x equals negative 4. Okay. There's my line. That was easy, huh? We're getting good at this. Okay, there's lots of ways to describe slope. One way is the change in y's over the change in x's. That's one way. You could also use the slope formula, but it looks to me as if I'm going up by 2, up by 2, up by 2, right? For my x's. So my change in x's are 2. My change in y seems like it goes up 5, up 5, up 5. So my change in my y's is 5. There's my slope. You could also graph it and find it. You could use the slope formula, and that would also work. But this is kind of the easier way. Change in x's. X's are changing by 2's over the change in y's. Y's are changing by 5's. So y, 5 over 2. Mars?
I was just wondering why it was 5 over 2 if x on that one is x is on top.
That should be a y. Does that look like an x? That could be my fault. So it's always the y's. Slope is always the y's over the x's. Always, okay? It's because it's rise over run, right? Good. Thank you for asking that question. Okay, last two. All right. Tickets are sold at a dance for $35. At least they used to be, not anymore. Now you can't charge anything, right? Anyway, that's another story. The cost of the gym trend is $100. The income equation is I of n equals $35 minus 100. Represents the income of the dance, right? Minus 100 because you got to pay for the gym, right? What is the independent? You guys really messed this up last time. Let's not mess it up this time, okay? Independent. So what? The independent is the variable that we can decide, okay? The dependent variable is what happens after. So the independent variable is how many people go to the dance, right? We can say, hey, let's get together. We can choose. In fact, me and my buddies, we're going to the dance. So the 4 of us go. We get to decide that, no, sorry, girls, you can't. Can't go. That would be a silly dance, wouldn't it, without the girls? Sorry. We'll say, we want to invite the girls. We get to decide. We are independent. The independent variable is n, because we can decide. N is the independent variable, which is the number of people. It's also the main variable. It's also going to be the x or whatever it is, okay? Now the dependent variable is like the y. Independent variable is like the x. The dependent variable is like the y. And in this case, what's dependent is going to be income. Depending on how many people go, that determines our income, okay? So it's I, which is our income. Does that make sense? Okay, now, if 150 tickets were sold, what would be the income? Well, okay, this is like two different questions. Here's question 1, and here's question 2, okay? So I'm just going to use my formula. I'm going to put in, just plug in 150. So I'm going to go I of 150 equals 35 times 150 minus 100. I'm just going to use a calculator, right? I'm going to do that. Just going to go my 35 times 150 subtract 100. About 5,000. Ooh, see how much money we used to make in the old days on dances? That way all the seniors could go on a senior trip. Now we can't raise any money, can we? I don't know what you guys are going to do, because can you imagine? That's how much they used to make on homecoming and prom.
Wow.
Well, $35 a ticket's not much, right? And they used to sell them for even higher than that, right? 50 bucks a ticket, right? So now, if we need 7,705, so we're going to set the income, 7,705 equals my 35n minus 100. Let's just solve for 35. 7,805 equals 35N. Divide by 35. And we need about 223 people to come to our dance, and we'll make that much money, okay? And